Students, myself Annama VB of Holy Hearts Educational Academy Raipur. In this video, I am going to tell you about the class 9 subject science chapter 8, which is motion. In this chapter, first of all, we understand the meaning of the word motion. When an object is said to be in motion, when it changes its position with respect to its reference point. On the other hand, if an object does not change its position with respect to the reference point, then that object is said to be at rest. So, here we'll see different types of motion, that is, first one is linear motion, second one is the circulatory motion, and the third one is the oscillatory motion. Now, what is the meaning of linear motion? When an object moves in a straight line, then we say that object is in linear motion. If the object moves in a circular way, then we say that object is in circulatory motion. When the object moves to and fro, for example, you are seeing the pendulum moving to and fro, that type of motion is known as the oscillatory motion. Now, we'll see what it means by the term physical quantity. It is the physical property of the material that can be measured, is known as the physical quantity. They are of two types. First one is a scalar quantity and the second one is the vector quantity. Scalar quantity means those quantity which shows only the magnitude, which has only the magnitude, then we say that it is a scalar quantity. For example, the distance, which has got only the value or the magnitude and the speed. The second one is the vector quantity, which says that the quantity has got both magnitude as well as the direction. The direction, it may be various directions such as east, west, or north, or south, or to the left, or to the right. For example, we have velocity, acceleration, displacement, momentum, and force. All this comes under the vector quantity. Now, in this chapter, we are going to learn about various physical quantities of motion such as distance, displacement, speed, velocity, acceleration. Apart from this, we are going to learn about the uniform motion and non-uniform motion, graphs, and the equations of motion. Coming over to the first physical quantity, that is distance. What does this term means? The distance, the actual path length traveled by an object is known as the distance. And it cannot be zero. The second physical quantity is the displacement. It is the shortest distance between the initial position and the final position of an object. It is a vector quantity and it can be positive, negative, or zero. Its SI unit is meter. So this gives the differences between the distance and the displacement. Distance is the actual path traveled by an object, whereas the displacement is the shortest distance between initial and final position. Distance is a scalar quantity, whereas displacement is a vector quantity. Distance is always positive and cannot be zero, whereas displacement can be positive, negative, and it can also be zero. The next physical quantity that we are going to learn is speed. Speed is the distance traveled by an object per unit time. This, we use this term usually. What is the speed? So how we are going to find out the speed of an object? The speed of an object can be calculated using the formula, that is distance traveled by that object divided by the time. It is a scalar quantity and it is always positive and its SI unit is meter per second. The second term that we are going to learn is the velocity. The distance traveled by an object per unit time in a given direction. Or in other words, we can say the speed with direction, we can term it as velocity. It is a vector quantity because it has got direction, and so it can be positive, negative or zero, because displacement, when displacement is zero, the velocity will be zero. Now how to find out the average speed? You know that when an object travels, it does not travel with the same speed. Sometimes it decreases its speed, sometimes it increases its speed. So we should know the average speed of an object, which is calculated using the formula average speed is equal to total distance upon total time. Similarly, the average velocity we can calculate using total displacement upon total time, or one more formula is there when we know the initial and the final velocity. It is given by v minus v plus u upon 2, or initial velocity plus final velocity upon 2. Now we'll see what are the various types of motion. First one is uniform motion. That means when an object travels equal distance in equal interval of time. That means if it covers equal distance for every 10 seconds, if an object covers 10 meters, then we say that object is traveling with the uniform speed. On the other hand, if it is not moving with the equal distance, or it is traveling with unequal distance in equal interval of time, then we say that the object is non-uniform. For example, if an object travels for every 10 minutes, if the object for the first 10 minutes, if the object moves 3 kilometers, and for the next 10 minutes, if it moves 4 kilometers, then we say that object is non-uniform motion. The next term that we are going to learn is acceleration. What does acceleration means? The rate of change of velocity of an object is called acceleration. I repeat, the rate of change of velocity of an object is called acceleration. This acceleration is denoted by the letter small a, and it's given by the formula a is equal to v minus u upon t. V minus u upon t is the change in velocity. V minus u is the change in velocity, where v is the final velocity, u is the initial velocity, and t is the time taken. It is a vector quantity, so it can be positive or negative. Now, this negative acceleration is also known as deceleration or retardation. and the SI unit of the acceleration is meter per second square. Now what is this positive acceleration means? When the final velocity is more than the initial velocity. When the final velocity is more than the initial velocity, then we say that the object is in positive acceleration. Otherwise, if the final velocity is less than the initial velocity, then we say that object is in negative acceleration. Now the next term is the graphical representation of motion. We know that if anything is graphically represented, then it is easy to follow. That's why the motion of an object is represented graphically. Just by observing the graph, we can understand the motion of an object. The first motion of an object is this, where we take time as x-axis and distance as the y-axis. If we have the straight line like this, making a slope, then we say that the object is in uniform motion. Now, if this line is parallel to the x-axis, then we say that the object is not moving or the object is at rest. Now, seeing the slope of the line, we can also say which object is moving faster and which object is moving slow. If the line is not straight and it is making a curve, then we say that the object is in non-uniform motion. So here we have learnt about the distance time graph, and the next one is velocity time graph. In velocity time graph, we are going to take time as the x-axis and the velocity as the y-axis. So if the line is parallel to the time axis, then we say that object is moving in a constant velocity or uniform velocity. If we have a straight line making a slope with the x-axis, then we say that it is moving with a uniformly accelerated motion, that it is increasing its speed gradually in a uniform rate. Now, from this graph, we can find out two things. That is, by finding the slope of the line, we can calculate the acceleration of an object, as well as by finding the area under this graph, we can find out the distance traveled by the object. Now, using this concept, we are going to calculate the equations of motion. Equations of motion by graphical method, which is the one of the important topic of this chapter. We know that there are three equations of motion, which is named as first equation, second equation and third equation. Now, the first equation is also known as velocity time relation because it contains velocity as well as time, which is given by v is equal to u plus at. The second equation is known as the position time relation because it contains the position as well as time. It is related and it is given by s is equal to ut plus half at square. The third equation is known as the position velocity relation. It is given by 2as is equal to v square minus u square. Now, we are going to see how these equations are derived using graphical method. So, Using the graphical method, we need the graph of velocity and time, where AB is a velocity of an object moving with a uniform velocity. So we know that the slope of the velocity time graph will give you the acceleration. The slope of the velocity time graph will give you the acceleration. And slope is given by the formula y-axis upon x-axis. Now, we need the slope of line AB. So, AB is given by, what is y-axis here? It is equal to BD. And what is x-axis here? It is equal to AD. So, BD upon AD. Now, we can write this BD as BC minus DC. We will get the BD. That is BC minus CD, we will get BD. BD is equal to, you know that the entire line BC can be written as BD plus DC. So, BC minus CD will be equal to your BD. So, this line will give you the acceleration. So, AB is given by A, and the length of BC, this is the final velocity. So, BC is given by V, and the length of this CD is equal to U upon the length of AD is T. So, rearrange this, we will get AT is equal to V minus U, and AT plus U is equal to V. V is equal to U plus AT. Moving over to the second equation of motion, that is S is equal to ut plus half at square. How did we get this equation? The same graph where we take velocity as the y-axis and the time as the x-axis. So, we have said previously that area under the slope will give you the displacement. So, we are considering the area of OABC. This diagram can be divided into two parts. First one is the area of the triangle and the area of the rectangle. Now you know that area of rectangle is given by the length and the breadth. So we have S is equal to, here area of OABC is given by area of rectangle plus area of the triangle. Area of rectangle is length, that is OC into OA, plus area of triangle is half base, that is AD, into height, that is BD. Now this is equal to, this BD can be written as, again this BD can be written as BC minus CD. Substituting the value, we know the length of OC is equal to T, the length of OA is equal to U, and half AD is given by the length T, and BC is V, and CD is your U. So, we get UT, because T into U is equal to U into T, both are same, plus half T. From the first equation, we get that V minus U is equal to AT. So, S is equal to UT plus half AT square. Moving over to the third equation of motion, that is position velocity relation. Again, we are considering the same thing. Area under the slope will give you the displacement, which is the area of OABC. And this you can see that it is in the shape of trapezium. Using the formula of trapezium, half into, sum of these are the parallel sides. OA and BC are the parallel side, and the distance between them is OC. S is equal to half. The length of BC is U, V, and length of OA is U, into distance between them is T. Now, substituting the value for T here from the first equation, we get V minus U upon a. Now we have here in the denominator we have 2 and a. We have denominator as 2 into a. We have s is equal to v plus u into v minus u. From the formula a plus b into a minus b, we get a square minus b square. So we have v square minus u square. 2as, we arranging this, we get 2as is equal to v square minus u square. Coming over to the last topic of this chapter, that is distance and speed of a circular path. Now, for a circle, complete circle, we know the formula that distance is equal to 2 pi r. The pi value is 22 by 7, and we know the speed formula. Speed is equal to distance upon time. So distance we have 2 pi r upon time. So hope students you might have understood these topics. Thank you. Stay at home. Be safe.